we should move to Dr. Ahmed Rassili.
Yes.
Is Dr. Ahmed Rassili is there?
Yes, he is there.
Very good, thank you.
Here I am, guys.
So good evening, Dr.
Good evening.
Rassili.
Assalamu alaikum. Hello, sir.
Marhaban. So how is in Belgium?
Oh, in Belgium, but yeah, everything is nice. It's raining like hell since few days.
Okay.
I think we have storms all days, and it's a heavy rain. So well, but this is Belgium. So
here in Berlin is very nice.
Yes, yes. I was in Hanover last week, and it was also nice. I was in Munich also. So
okay. So I'm going to present you a little bit.
Thank you so much. Thank you so much. I don't know how many people are connected or are attending in front, so it doesn't matter.
I don't know. Science in Morocco is a little bit.
Yeah, it doesn't matter.
They prefer something else, maybe. Okay. Anyway, Dr. Ahmed Rassili, he's a member of the Virtual Learning University since the beginning. He will present a talk today, but he's in charge of a syllabus on recycling metals, especially. So he has his PhD in theoretical physics at the University de Liège, this Belgium, and conducted his career on R&D in both Department of Electrical Engineering and Aerospace and Mechanics as a postdoc, then a research director and associate professor on advanced manufacturing. He gained a teaching experience working at the University of Liège, the German University of Technology in Oman, and Euromed University, dealing with applied thermodynamic, fluid dynamic, thermal power station, and manufacturing process for automotive sector. Since 2016, he started a new career in business development in a research center, mainly focusing on advanced manufacturing, recycling, and waste valorization sectors, including other activities such as zero waste, circular economy, energy efficiency, and digitalization. Ahmed Rassili has developed a well-known experience in grant management in European funding program such as Eranet, maybe he can talk about it, Horizon 2020, this we know it, and Horizon Europe Cost Action. I am also in this Cost Action as well. I don't know if you know this. Anyway, we just won it few days ago. So I want to thank you very much because you are always there when we need you. And you will talk about your favorite topic from urban mining to high added value products, integrated solid waste management, the case of metal. So
yeah. And I will also add a last chapter, but it will be a 5 minutes video at the end concerning the project for the end of life of solar panels.
It's fine.
So it's in conjunction with the topic of the conference itself. Well, I don't know about the public whether it will be in French, in English, or
as you like. If you want to talk,
let's do it in all languages, whatever the understanding could be. Let's go with English and see if there are some.
Myself, I speak in English and sometime in Arabic, but
yeah, I'll try to do it in English and see what if French is needed. I can switch to French. It doesn't matter. I will do it in both languages. Like
easy. Now share with us your presentation.
Yes, I will do. I'll do. Zoom share.
So there is a green.
Yeah. Just I will just take the right presentation and share it. And I think it's the case here. Lower this.
Then make it bigger.
Yes, I will reach this to. Is that okay?
Yes, fine. Very good.
Yeah, as you already mentioned, it will be dealing with urban mining and how to make waste not waste enough, but also co-products as raw material for new products. So this is what we call the urban mining, because, well, we urban mining because it's linked to the waste generated by our industries, by our houses, and all over the world. So like I started last time, so there is no planet B. So we need definitely to think about the solutions in order to save the planet A, that our planet. But everybody is aware about what is happening to climate, for example, and what are the facts and what are the solutions also, and to reduce our footprint. And reducing our footprint means that also reducing the quantity of waste we are generating, and at least try to recover this waste and make something with it. So we need simply to wake up and make some change. Just I'm giving facts like I did last time. So these facts, the first of the facts is the CO2 emissions, which is generated worldwide, and it's a huge number of billions of tons. So I think we cannot. These are the member states of Europe, the America, the India, and all China, all these industrialized, let's say, countries, and the numbers are still growing. And everybody noticed that during the first COVID crisis, there was a reduction of these emissions. That means that the CO2 emissions are linked to the human activities, and these human activities are generating a lot of CO2, but generating also a lot of waste. The second fact is that we are using minerals and metals, as I said, in a greater quantity than before, because our needs are growing too much. You are speaking here, for example, for the generation of renewables, for example, we are using a lot of silicium, a lot of glass, a lot of wires, copper, and other, let's say, critical raw materials and materials. So our needs, even if we are going, let's say, durable and sustainable, we are also using too much materials. So the main reasons, as I said, increased global population. As the population is increased, that means the needs are also increased, and the spread of prosperity across the world. I remember in China, for example, I visited China in 2010, and in 2010, which is only 12 years ago, less than 10% of the Chinese population had a car. Now I think they are reaching more than 35%. 35% of Chinese populations is something like 10 times Moroccan population and even more. So in the light of these trends, it has become important to ask if we can continue to provide minerals required in these demands, because I think the earth reserves are really limited, and I think the extraction of these kind of materials is really very exhaustive. So it is increasingly apparent that materials that have been incorporated into products no longer in use, they are called secondary materials or scrap. Some people call them waste or byproducts, can provide a valuable supplement to virgin stocks, because we can make these secondary materials really valuable and use them like primary materials, which coming directly from ore. So some solutions are linked to, as I'm speaking about waste, some solutions are linked to this waste. And then, well, as I'm living in Europe, I'm going to speak a lot mainly about waste framework directives coming from Europe, and I think that this also could be applied to other countries depending on the evolution. So sets this frame directive, it sets the basic concepts and definition related to waste management, including the definition of waste itself, the recycling and the recovery. But let's start from the beginning. The first stage is preventing waste. That the best waste is the waste we don't generate, zero waste. This is the most important, and this is the preferred option. But we cannot go over this solution, because we need to generate waste, because we need to live and to have products and to have quality of life. And then the opposite of this no waste is that sending waste to landfill, which should be also the last solution, because when you're sending let's say the waste to the landfill, that means you can no more recover it. It goes to earth, but it goes to earth. Earth can do nothing. Yes, for it. I will explain it later. And this directive requires also that waste must be managed without endangering human health and harming the environment, without any risk to water, air, soil, plants, and or animals, or without causing nuisance through noise or odors, and without adversely affecting the countryside or places of special interest. Those are the limitations that are included within this kind of directive. This directive also targets to comply with this objective. The countries shall take the necessary measures to achieve the following targets. So the first one is by 2020, the preparing of the reuse and recycling of waste materials. This should be at least a minimum of 50% by weight. Also by 2020, the preparing for reuse or recycling of other materials recovery, including backfilling operation, using waste to substitute other materials. And this target shall be increased to a minimum of 70% by weight. And by 2025, the preparing for reuse and the recycling of municipal waste, which is a huge amount of tons that are generated by human each day, that shall be increased to a minimum of 55 for 2025, 60 for 2030, and 65 by 2035. Let's go over a simple scheme. One can imagine that we can, let's say, I don't know if you see my mouse or. Okay, I hope you're hearing me.
Yeah, but move. We can see it. You are moving.
You can't see it. I thought.
We can see. We can see.
Ah, you can see it. Okay. So this is the mining. As everybody knows, Morocco is well known about mining, mainly phosphate. I'm coming from Khouribga, which is one of the biggest and huge mining, let's say, area in Morocco, and it means extracting, let's say, raw materials for the use, and this is put in the cycle of life of a product, from the material supply until the manufacturing and then production of part, whatever it could be copper, it could be iron, it could be silicon, it could be other materials, until you and me, until users, and then we starting loops. The first loop is that maintenance and then long use of a material. That means we give it a very, very, very long life. And I think this still one of the, let's say, the quality of the population in Africa or in Morocco, where a car, where a component really lasts for a long time. But in this case, when it's no more the case, should be at least collected properly and then try to recover, let's say, some products or some parts to reuse and sell, put again within the cycle in order to make preparing the new products and bringing them to the market and reusing them. And then definitely, if it's not the case, then at least sorting and dismantling correctly the product for a proper recycle in order to re-inject the reuse part and so on. But the last and which is not really the well-desired effect is that the final disposal, let's say, company, which will be just landfilling the material itself. So we extract from earth and we bring to earth. Somebody can imagine, okay, I extract from earth, I will bring to earth, maybe earth will do something with. But the constant time from this side extracting until the use, and from the landfill to the recovery of the material from the earth, it's really from here to here, it needs millions of years in order that the earth try by itself to transform the materials and make, let's say, new materials out of them. So we definitely should limit this kind because it's not feasible at all. So this is, as I mentioned earlier, the title of the presentation. I will give you just a short presentation on my company and Research Center of Metallurgy, CRM, and the activities we are dealing with. We'll speak a little bit about the facilities we do have concerning the circular economy, and then we'll speak about special projects, how we call it, why we call it urban mining, and how it works, urban mining, and what are the quality, what let's say the added value products we can get out of that, and put some conclusion. And as I said, I will add some minutes from a movie that was presented in local TV about the project, some projects we are running towards the recycling of photovoltaic panels, for example. CRM Group, it's a research center on metallurgy. It was created on 1948, just after the Second World War. It was for the first Plan Marshall, European Plan Marshall, in order to enhance a big, let's say, relaunch and the recovery of the European industry. And then CRM was created in order to support the steel industry. So our existence, our reason of life was to help the steel industry in order to gain, let's say, new products and new markets. But we have evolved. I will go even faster here. The presentation could be available if someone really needs it. It doesn't matter. So, and then we evolved towards and around the material, let's say, products and solutions and the development for different applications. This is our, as I said, is our DNA and core business. But we are also very active in the energy shift. I will speak a little bit about our development concerning the energy sector. We are active in advanced manufacturing, mainly the new, let's say, manufacturing processes like additive manufacturing, laser cladding, and all this repairing, because as I said, I was speaking about one of the solutions in order to recover the material instead of throwing out the, let's say, component, or because it's damaged or it's destroyed or it's a little bit fragilized, in order to send it to the landfill or in order to send it to recycling. Maybe if we can repair it, and if imagine these big components from marine, from aerospace, from many other sectors that are generating big components. So repairing these components is also now the actuality of use. So digitalization in Industry 4.0, it's also important in order to enhance, let's say, control of the manufacturing process themselves, in order to make, for example, if you generate a product, for example, we can put some tags on it, like RFID or something like that, in order for the traceability of the material itself. You know from where it comes, for which use it was manufactured, and then the purpose on of its usage, and then how to recover it and how to recycle it also. All this data could be now, let's say, targeted within a product. The main, one of the main activities is the circular economy. The circular economy within CRM is mainly dealing with metals. We are collaborating with other, let's say, partners and research centers and industrials for other types of materials like plastics, for at least material recovery, or for energy, waste to energy or waste to material, but also from minerals also. And also we have a department of construction for the application and the use of materials. So, well, as I said, for metals, I will not go in details. As I said, we were created for metals and metal processing, so we can really do everything concerning metals from ore until applications. Let's go over the plot. As I said, advanced manufacturing, I was speaking about different types of manufacturing processes. So we do have here from the design and casting of innovative and new materials, as I said, for aeronautic application, aerospace, for automotive, for many other applications. So we are, let's say, dealing with this innovative materials, mainly for additive manufacturing. We are also, let's say, performing technologies like hybridization, but we can not only, let's say, manufacture a product, you can also make transformation of the product itself in one line. Also post-treatment and the deployment of and industrialization of surface treatment for additive manufacturing. And as I said, repair of industrial parts to improve the durability, which is one of the aims of the project. Digitalization, I will not speak too much. We are developing a lot of solutions for the digital world, for Industry 4.0, and for the smart manufacturing. One of the important, let's say, things we do have at CRM, and we do have facilities for the printed electronics. And printed electronics is now gaining a lot of, let's say, sectors. Imagine for your car, for example, if you, for example, your car, you have your door, you have a lot of wires within the door, for example, and now you will no more need to have such a quantity of copper and wires inside the door. You can print everything in a door now. For example, you can print electrical circuits in a metal for sure, because printing it in another, let's say, substrate, it's feasible. but printed it in metals. For example, if you see in the right-hand side here of the slide, these are all electronic circuits printed within a sheet of metal, and it was deformed in order to have the shape it should be. We have also different facilities as really huge pilot lines for different, from roll to roll, in order to make this, let's say, activities used in for mass production. I will not say too much about the construction sector, but for the energy shift, for example, we are active in different, let's say, levels. Renewables, we are active in photovoltaics. We are producing now, as I said, we are active in the field of steel, and we are also helping the steel sector to promote durability and energy production. For example, if now you would like to let's say to have a roof, a big roof, and now you have in your roof, you can just install photovoltaic panels on the top of it. But now we have developed some solutions on which you come and you print directly your photovoltaic circuit within a flat products, which we know it's no more thick than few millimeters. And then inside this is called PV steel, and which you just print the photovoltaic layer on cells on the top. And then we have another project, which is steel bat, on which in the bottom level of the roof, you have for the batteries for the storage. So in a space of a few centimeters, you have your roof, you can produce on the top, and you can store in the bottom side of the level. We are also active in CO2 mitigation, because this, as I said from the beginning, CO2 is one of the biggest, let's say, problems within our industries. We're active in biomass, which is also, as we are producing, we're generating, let's say, a lot of waste, organic waste, and so on. And from this, we can not only, let's say, green waste could generate some energy or some material. So we're active waste to energy and heat recovery. But we are also active in the production of hydrogen. When you speak about renewables, like wind energy or photovoltaic energy, yeah, the problem of this intermittence, I don't know how we would call it in English. So you generate sometimes too much, let's say, energy or electricity, for example, but you just inject it within the network. But if you can use it otherwise, you can store it in a battery, for example, but you can store it and you can use electrolyzers in order to produce hydrogen, which you can use later, or you can use via fuel cells in order to reproduce electricity elsewhere. So these are the topics on which CRM is active. Energy, I mentioned many of them: hydrogen, renewables, and also biomass and other types of energy. But for circular economy, as I said, we are really very active. It's one of the biggest axes. And I think 2 months ago, we got a project from the government. We got two: one for the recycling of materials, about 12 million euro. And another one for the hydrogen production and hydrogen use within heavy industries, about something like 9 million euros. So for the next coming 4 years, we have something like 21 million euro in order to deal with these two topics. So circular economy is a huge, let's say, topic of let's say, activity. So starting from collecting, sorting, let's say, when I meant sorting, smart sorting, dismantling, and then let's say shredding, and after shredding, trying to let's say recover the materials. And people are dealing with physics know that there are two main, let's say, axes to recover the materials, either by hydrometallurgy, and you just to reduce to really small scale the material in order to use the density property in order to separate the materials, or the other parallel activity, which is dealing with pyrometallurgy, and then you just burn everything in a big furnaces that just to recover them by evaporation of materials, because they don't have the same evaporation temperatures. So these are the two main activities. CRM is active in pyrometallurgy, and then hydrometallurgy is the topic we are working with our partners in order to have a complete set of solutions for our industrials. So as I said, heat, yeah, we start from pre-processing, research efficient metal recovery, design manufacturing of circular product, which is really, really important, because if you want, for example, to dismantle properly a product, you need to have really think about that before thinking about the product, before manufacturing the product, in order to make it really, really useful to dismantle it. You need to eco-design it. But also there's a big activities I will speak about in electrical, let's say, components, electrical drives, windmills, special metals for batteries, PV panels, geopolymers for insulation, and additive manufacturing powders. So this, as I said, CRM can really help in developing solution within the lab scale until the implementation in an industrial level. We do have different scale of the industrialization of the let's say the recycling processes, and also we are supporting the industrials, you know, to pre-engineering and then before setting up their aspect. As I said earlier, digitalization is very, very important, because this is as one topic. In order to dismantle correctly or to recycle correctly a product, you need to know where it comes from. What is basically the chemical composition, or what are the materials available within it, which from which element from the Mendeleev table is available within this product, and then you need to tag it, and you have just scanning the product, and you know this product, you have all let's say the list of the content, and then you recover all this map by using different types of sensors of analysis, X-ray, LIBS, and image analysis, and many other stuff. We'll see it later in the presentations. As I said, well, different recycling topics. I will not go in detail, just prefer that we can exchange a little bit on that, and if you have some questions, let's go for the. Also, we deal with modeling and characterization, because this and life cycle assessment, which is really important for the environmental impacts. In global, from lab to pilot scale technologies for the processing recycled material, these are all available. Separation and sorting, as I said, conditioning in order to prepare the materials in order to be used. Definitely, it should be prepared, dried, pressed, bricked, compacted, and pelletized, because you cannot just take a given waste within a given, let's say, geometry and dimension, and you throw it in your furnace. It will just burn and give you a smoke. But you need to prepare it and make some what we call the pellets or something like that. And as I said, the thermal processing is the most important, let's say, process. Fixed and fluidized bed, rotary furnaces, and rotary kilns, and heating also under vacuum, because sometimes in order to avoid the evaporation of some materials, you need to work, or oxidation, because this is a very, very, let's say, big problem within this kind of types of industry. You heat, you have oxygen, and then instead of recovering the material, the metals, you are producing oxides, and oxides, it will be difficult to recover the materials from the oxide. These are the type of smelters and this new coming equipments. We have different kind of equipments, from the kilograms to hundreds of kilograms to many liters, and to different capacities in terms of watts. We have run one project, for example, for the metal industry, for example, and we see how we can recover different types of aluminium, for example. And recovering aluminium, you have aluminium coming from industry. For example, if you go to these car collectors, the car collectors, you have the motor block, which is mainly in aluminium. This is easy to dismantle and to use as a proper aluminium material. But you have also different types of aluminium which are existing everywhere. You just take a plastic bag of chips, for example, and it contains some aluminium. It's less than 1%, but it contains some aluminium. You just buy a lasagne and you eat your lasagne. What you do with the bucket of the lasagne, sometimes you just throw it in your trash as waste. But all these types of metals, we are just sending them to incinerators, it will have no value for let's say it could have some energy value, but it's not the aim. If we bring all materials to energy, then it's nice because we don't have energy, but we'll have no more materials. We need definitely to have energy, but we need also to recover, let's say, materials themselves. And then we just run a pilot within the 250 employees of the CRM and say, okay, everybody who is generating some aluminum waste, it could be from mid-scenes, it could be from waste aluminum films we are using for your sandwich or whatever, and ask people, and I'm giving them bags, CRM bags, and each one has one in his kitchen, and people are collecting this kind of waste and bringing it to the CRM, and we prepare everything, and then we mix these types of source in order to obtain a good mechanical behavior in briquettes, and then in order to enhance the melting, and then we cast this aluminum, and it was amazing. So this type of waste we have collected, and this waste, everybody knows about it. You go to a restaurant, you will see all this in a trash. You have everything here. There's candles, you have cannets, you have, let's say, drinks, you have, this is the aluminum film, this is chips and everywhere. But you have also in parallel some industrial collection of some let's say later pure materials, because we need to have a collection and a mixture of different type of waste in order to make this mixture and have good products. And then this is simply shredded. It's like it contains a lot of plastic here because, as I said, sometimes you have just 1% of aluminum within a product, and then you need to shred everything and mix everything. If you put all this plastic, for example, in a furnace, it will give you smoke. But what we did in CRM, we tried to recover the plastic energy, which was here, in order to melt the existing aluminum. So we have a process is already patented. And then we recover the energy from the plastic to melt the aluminum itself, and to go on before melting. As I said, we prepare this kind of briquettes, and here you do have every types of aluminum here coming from local houses. And then after that, we cast the products, and we prepare some ingots. This is, you need to work under salt production like NaCl or KCl, otherwise you will oxide or your aluminum. And then we obtained, let's say this is the liquid aluminum coming. This is just was the furnace for test. And when we obtained these ingots, and these ingots were used in order to prepare some powders. And this powder was used to produce very qualified, let's say, aeronautic components, which now imagine the waste, you don't think about it, and you are just having your small film of aluminum or aluminum from your waste. You are, as I said, everybody now will be looking around him and see what types of aluminum he's generating. And imagine that out of this normally called waste, you're generating a high value product, which is really powder for aeronautic component, which is really very, very, very interesting. And then the results of this project now, as it was successful and with a high rate of recovery, now we are building a, let's say, company that will be dealing from the it will be ready for the next coming 2 years, dealing with 20,000 tons of this kind of waste, and the capacity of the factory will be 40,000 tons of this kind of waste. And this is reality. This, as I participated to build the business plan of this company, and this company now is still on the paper, but the paper, everything is validated. The concept, the contracts are validated, and then I hope that I will invite you for the opening of this let's say factory in the next coming 2 years. Keep fingers crossed. Now for the conclusions, I'm speaking a little bit about some paradoxes of the development and the innovation. And for example, these paradoxes are all linked. You have the environment and related energy aspects. This is really an important point. Beside that, you need to run circular economy, but all this is driven by the economical aspect and competitivity. You need definitely to deal with that. And last but not least, you have some social aspect. The social aspect, we spoke about water contamination, we spoke about health, about all the stuff. But all this is linked. This you cannot deal with one process and forget the other one, and vice versa, and so on. And in order, for example, I always like this example. People who are following the, let's say, the evolution of the wind turbines. We start from the 19th century. It was 1 to 12 kilowatts, let's say, wind turbine, and now we're running 50 megawatt turbine with a huge amount of money. But in order to have this, and the first one here for the 19th, it was some wood based and some iron, and just some metal within it. At least very few elements of the Mendeleev table. But if you have a look on the new generation of these wind turbines, we are using a lot of elements from the Mendeleev table, and it means that we are using a lot of different materials. And then here you can at least separate two materials very easily. Here you have many different materials. You have the drives, you have the cables, you have the electronics, you have a lot of stuff on it. And another example to the bulbs lamp. The bulbs lamp was just a small tungsten filament here. Let's say CFL, and then we have a LED, and with the LED you have at least, I think, I can speak about 40 to 42 elements from the Mendeleev table. So definitely we are really has some complexity within the waste management, and then we definitely need to have some respects, and then respect some hierarchy. Though I'm back to this let's say figure I mentioned in the beginning. We avoid the disposal, because it's all linked to health. Because you can say that in some countries some people are living using that, but why not employing these people in factories where we dismantle, where we separate, and we can, instead of having them working in a very dangerous condition for them, why not just before arriving to the situation of everything is in the landfill and people go there to collect plastic, to collect metals, to collect everything? Why not just installing some regulation in order to have collections just before the collecting from houses, and then people, instead of working in bad condition, could work in really interesting condition and work a little bit in a higher level of waste recovery and so on. So in order to deal with all this, as I spoke in the beginning, eco-design is very important. The end of life thinking when manufacturing, we just need, we don't need to mix a lot the materials, because the design should be done for recycling. And design for recycling means that we can easily dismantle and separate the elements. Design for circularity, design for recycling, human-centered developments. I thank you so much. But as I said, I promised, there's a small movie. If you I can share again the screen in order to just show you this. Let me share the screen for this quick time here. It's 5 minutes, if you don't mind, if you still have some time, Professor.
Yes.
Just you see what in 2 times what we are doing with end of life, let's say photovoltaic panels, because it has to do with finally, as the colleague before me showed, that there's some degradation, and finally it will the photovoltaic panel will reach a certain level. Well, you can no more use it, but what to do with it? Better if you can recycle it. So if you see the screen now.
Yes.
Une question à présent, comment sont traités les panneaux photovoltaïques en fin de vie? Eh bien, le secteur industriel s'organise depuis quelques années pour faire face au défi du recyclage qui sera toujours plus important dans les années à venir. Gilles Lejeune et Jean-Noël Lemar nous emmènent à Serein dans une entreprise qui travaille au démantèlement et à la revalorisation des panneaux.
Malgré les changements qui touchent les mécanismes de soutien aux installations photovoltaïques, l'énergie solaire suscite toujours l'intérêt des consommateurs. En juillet dernier, la production d'électricité générée par le secteur a d'ailleurs atteint un pic record sur notre territoire. Mais un chantier colossal pointe à l'horizon. Comment allons-nous gérer le recyclage des panneaux solaires? En février dernier, un groupement d'intérêt économique appelé Solaire a été créé avec un objectif double, le démantèlement et la revalorisation.
Nous prenons les panneaux entièrement. Donc, les panneaux entiers arrivent ici. Ils sont habituellement sur palette. Nous les démantelons et nous obtenons, suite à ce démantèlement, ce que l'on appelle un laminé, donc, qui est constitué du panneau, mais sans le cadre et sans les différents câbles qui vont vers l'onduleur. Alors, vous voyez à l'intérieur les petites cellules et les connecteurs intergaufrettes. Dans un deuxième temps, l'objectif est bien sûr de récupérer tout cela.
Dans 5 ans, la filière s'attend à devoir traiter pas moins de 80 000 tonnes de déchets liés aux panneaux solaires en Europe. Et les chiffres ne cesseront d'augmenter par la suite. L'industrialisation de la filière recyclage devra alors être prête à gérer cet afflux.
Il y a déjà quelques centaines de tonnes qui sont disponibles à travers notamment des déchets de manufacture, à travers des intempéries qui nécessitent des changements de panneaux. Donc, à ce niveau-là, il y a déjà suffisamment de matière pour commencer le travail. Néanmoins, ce n'est que d'ici 5 ans à peu près, en tout cas ce que les études laissent présager, qu'il y aura suffisamment de matière pour lancer un procédé industriel à part entière.
Le recyclage ne cherche pas seulement à réduire le volume des déchets, il vise aussi à limiter la quantité d'énergie grise. L'objectif est de limiter les impacts environnementaux liés à la fabrication des panneaux solaires. Dans le cadre du plan Marshall 2.0 vert, le laboratoire GreenMat a été un partenaire des industriels.
L'idée était de mettre un procédé en place relativement écologique, donc c'était d'éviter évidemment la combustion du panneau solaire et récupérer les différents éléments qui le composent. Dans ce cas-ci, nous avons mis un procédé relativement soft, comme on peut le dire dans le domaine de la chimie, et donc à base d'eau, de manière à pouvoir désencapsuler les différentes couches de panneau. Donc le laboratoire GreenMat a mis au point un procédé qui permet finalement de désencapsuler les différentes couches d'un panneau solaire. La première étape consiste à enlever ce cadre aluminium pour récupérer finalement le panneau solaire, le sandwich comme vous voyez ici. La seconde étape consiste alors à désenclaver, enlever les morceaux de verre comme vous le voyez, pour récupérer un verre relativement propre qui peut rejoindre une filière de recyclage. Par après, nous allons attaquer les différents morceaux de cellules photovoltaïques de manière à pouvoir en extraire d'une part les métaux et d'autre part le silicium sous forme de poudre.
Le silicium est un autre élément qui constitue les panneaux solaires. Celui-ci sert essentiellement à transformer la lumière du soleil en énergie électrique. Sa revalorisation présente un intérêt économique d'envergure.
Donc le silicium était au départ un matériau qui était assez peu valorisé, uniquement au niveau de la métallurgie, donc avec une valeur ajoutée relativement faible. Et depuis quelques années, des études scientifiques démontrent que le silicium pourrait être très intéressant dans le domaine des batteries, pour substituer une partie du carbone qui se trouve dans nos batteries, par exemple de GSM. Il y a une capacité qui est 10 fois supérieure à celle du carbone, on comprend donc tout l'intérêt. Et au GreenMat, la nouvelle génération, c'est d'essayer vraiment de récupérer ce silicium et de le valoriser au travers de batteries.
Ces différentes techniques permettent aujourd'hui d'atteindre un taux de 95% de recyclage des panneaux solaires. La Belgique fait figure de bon élève à l'échelle européenne. Reste à voir comment notre industrie s'adaptera aux défis de demain.
Voilà.
Okay. Thank you very much.
You're welcome.
Ahmed Rassili. So now I will ask Ustad Salim to take the floor. Ustad Salim.
Thank you, Professor Ahmed Rassili, for your presentation and for the video also. Let's move also to the Q&A and or comments or questions. Waiting for the participants to share their questions. Anyone, you can raise your hand or you can write in the chat. Okay, Prof. Ahmed, you can go ahead.
Yeah, I have just one question. What this know-how, what you accumulate during all this year about the recycling, do you think it can be transferred to Morocco and to make some business in Morocco or whatever?
Yeah, it's easy to transfer. Why? Because as far as you think on circular economy, let's say basis, you can create this kind of filières everywhere in the world you want. Yeah, as I said, there are some patents and some IP just to respect, because you cannot just say, okay, 1, 2, 3, you can transfer everything, but we can help definitely those who want really to start really thinking circular economy and valorization of different materials, waste materials. Now we're speaking in general. It could be metals, could be other materials. Yeah.
So you think that it's possible that we approach some people, they have money?
Definitely.
And to try to see if it's possible to do something. Yeah,
yeah, it's possible. As I said, CEREM is creating processes, and these processes are transposable everywhere.
So let's maybe on behalf of the VLU, we can make a small task force and discuss such possibility.
Yes, definitely.
Maybe
definitely.
we can do it. If there are some people in Morocco interested to join us, we will see. It will be
because waste is generated everywhere, and if it's treated and it's valorized where it is generated, it's even nicer.
Yeah. Okay. Thank you very much. It will be until for the moment for the photovoltaic. It's too early for Morocco.
Yeah.
But for electronic, for example, a lot of people they have 3 iPhone,
mobiles, computers, a lot of stuff.
Computer and all this stuff can be recycled.
Yeah, you can really recover a lot of raw materials.
Let's discuss this another time together with other colleagues. Yeah. Thank you very much.
Okay. You're welcome. You're welcome. I don't know if there are.
So thank you, Prof. Ahmed Rassili.
You're welcome. It's a pleasure.
We end with day 2, and Prof. Ahmed Anawi, if you present the 3rd program for tomorrow.
So tomorrow there will be a program very interesting, but I don't know how people in Casablanca are ready to be with us. That's the big question. Let's see first this program. If you give me just a small break to find it out, and that's the number 9. Yes. Okay, and then I will just put it here. I will share the screen. Yes, yes. Oh, what's that here? Oh. Okay. I don't understand what's going on here. Just give me small time to do it. Do you see my screen? Yeah.
Yeah, we see.
So it will be different conferences. Tomorrow again, we will have with us Thomas Hanabil. He is working on hydrogen by mimicking the nature, the leaf, and he will talk about his topic. Then we have a very famous also speaker, Nasruddin from Switzerland. He will talk about perovskite and his progress. I will talk about some result or inject printing of material and research opportunity in photovoltaic. Then we have 2 speakers in Arabic, one from Palestine, Ustad Ramiz Mahdi, and another one I think from Mamlakat al-Bahrain, if I'm correct. And he's the Wahib Isa, Dr. Wahib Isa Nasser, Ustad Aidan. And we have from France another colleague. He's working on passive building, and he will talk about the building and system performance. So it's all of them are very good talk. If there is time, I will again come back with some course about connecting students. Otherwise, we will stop by Professor Mankibi Muhammad. That's the program for tomorrow. Of course, I cannot promise you that the floor will be in Casablanca because people are apparently very exhausted for 3 days work. So it can turn out that it's only Zoom talk, not Zoom plus not hybrid. So we will see tomorrow. But in the morning, it can be that both of them, but in the afternoon, maybe not. So I want to thank everyone who was with us and all speakers who helped us to do this good job. We had a very good talks today. We discussed many good things in global manner and also about the photovoltaics. So I think I'm very happy that we did this initiative, and I hope we will have other initiative in the future.
It's annual meeting, Professor? It's an annual meeting, this might
No, this exhibition is every 2 years.
Okay.
2 years, yeah. But we will have maybe opportunity to meet again and to do some.
Yeah, now if it's open now to meet physically, it's better that some
of course
colleagues from Blue could be meet in a given.
Yeah. We will see. We will have many opportunity, I guess, but we'll see. We will take every opportunity in the future if we have to meet in Morocco, in Bahrain, or whatever. We will try to do it. Yeah, sure. And to see. And so, thank you very much. I will give the word to Ustad Salim, please.
Thanks, Prof. Ahmed. Thanks, Prof. Rassili. And thank you for all the participants today in the second day of the VLU conference. So inshallah, we are going to meet you tomorrow morning at 10:30. Thank you.
Okay. Thank you very much.
Thank you so much.
So,
Assalamu alaikum.
Have a good day.
Good day. Bye-bye. Thank you.
Bye-bye.
Thank you.